Okay, so we are solving systems of equations, and we're going to do this with substitution. There's also a way to do this with what's called elimination, but we're going to do substitution today. So the idea is that we have two equations and two unknowns, both x and y, and so we're assuming that they meet at some point. There's a point at which at least one, but in this case they're two lines, so there's just going to be one point where these two lines intersect. They meet. Although there could be no solutions or infinite solutions, but we're not going to get into that today. You see that these two equations here, y equals negative 2x plus 7, this is what y equals. And then we have another equation, x minus 2y equals 6. If we think about what y equals, which according to the first equation is negative 2x plus 7, the idea is that we're going to substitute that in for the y in the second equation. Okay, so in other words, we're combining the two equations by putting what y equals into the second one. So I'm going to rewrite the second equation, x minus 2, but instead of y, I'm going to write what y equals. Okay, and in this case, y equals negative 2x plus 7. So what I've done is I've made one equation with just x in it, and now I can just solve for x, right? So to get x by itself, I'm going to distribute this negative 2, right? So I have x plus 4x minus 14 equals 6. I'm going to combine these two. 5x minus 14 equals 6. I have 5x equals 20 and x equals 4. Okay, so I have x equals 4 here, but the idea is that if these are two lines, they intersect at a specific point, I want that point, and that point is x comma y, and all I have is x. So how do you think we're going to find y here? Yeah, we're going to substitute this back in to one of the equations. Which equation should we use? It actually doesn't matter. Okay, I can substitute this back in to either one. Okay, now in this case, I'm going to substitute it back in for into the first one, y equals negative 2x plus 7. Y equals negative 2 times, in this case, 4 plus 7. But I could use the other equation if I wanted to. All right, so let me just make sure that you see what we're doing there, right? So now I'm going to figure out what y is. Negative 2 times 4 is negative 8 plus 7, so y is negative 1. So my answer is 4 comma negative 1. That's the point that they both intersect. Okay, now I could check this by double checking, plugging it in to each equation. Y equals negative 2x plus 7, right? That's negative 1 equals negative 2 times 4 plus 7. Negative 1 equals negative 8 plus 7. Negative 1 equals negative 1. Yeah, it works for the first one. And if I plugged it into the second one, instead of x minus 2y equals 6, it would be negative 1 minus 2 times 4 equals 6. Negative 1 minus 2 times, oh, you know what? I messed that up, didn't I? I messed that up. I'm putting the wrong numbers in the wrong places. So if I have 4 minus 2 times negative 1 equals 6, 4 plus 2 equals 6, so that works, right? Both of those are true, so I just confirmed that this is my answer. Okay, so that's solving by substitution. Now, if I had a situation where the two equations, one of them wasn't just already solved for a variable, what I could do is I could solve one of them for a variable. So in this case, I have x minus 2y equals negative 2. What I could do is I could get x by itself by adding 2y to both sides. X equals negative 2 plus 2y. And then, again, I would substitute this into the other equation. I would substitute it in right there for what x equals. Okay, so you can picture how we could do that. All right, and that's the idea of solving equations by substitution. Cool. I hope you learned a thing or two. Thanks for stopping by.